Thank you, everyone. And I wanted to introduce Dr. Eva Carro. She is from the University of Madrid. She's a neuroscientist. And today we will hear her fascinating presentation entitled Decreased Salivary Lactoferrin Levels in Alzheimer's Disease. Eva, thank you so much for joining us.
Thank you so much. Well, first of all, I would like to thank the organizers for inviting me to participate in this session, and especially, of course, Dr. Lavinia Alberi. As the previous speaker, Dr. Pitzker, perfectly introduced, Alzheimer's disease is the most common neurodegenerative disease, and in the coming decades, global Alzheimer's disease prevalence is projected to reach higher epidemic and economic levels. Clinically, Alzheimer's disease is characterized by early deficits, followed by a decline in other cognitive functions. And pathologically, Alzheimer's disease is characterized by amyloid beta accumulations as extracellular plaques, hyperphosphorylation tau as intracellular tangles, and chronic neuroinflammation followed by the loss of neuronal cells, mainly in the cerebral cortex and hippocampus. But despite the advantage in the knowledge of Alzheimer's disease pathology, the mechanisms of action involved in this pathology are still not clearly understood. In these last years, many studies have been published reporting that brain infections may play an initial role in the development of Alzheimer's disease. This pathogen hypothesis is not a new hypothesis. It was already proposed by Oscar Fischer more than 100 years ago. Later, but all these studies from the Dr. Ruth Izaki. And in the following years, several studies postulated that brain infections with pathogens as bacteria or viruses may play an initial role in the amyloid plaque formation and development of the Alzheimer's disease through the inflammatory activation. To protect against these pathogens, these infections, antimicrobial peptides are an essential component of the innate immune system. These antimicrobial peptides and proteins are important defensive elements by inducing a broad action, a broad spectrum of antimicrobial actions and effects against these pathogens. And they may act directly with the microorganism membrane, or indirectly modulated host immune responses and immune system cells. The role of the antimicrobial peptides in Alzheimer's disease has been discussed in these recent years. And these antimicrobial peptides are produced and secreted from a number of secretory glands, including salivary glands. In fact, in saliva, lactoferrin is one of the most abundant salivary antimicrobial proteins and represent a first defensive line with many biological functions, not only antimicrobial effects, but lactoferrin is able to regulate inflammatory activity. It's also also have antioxidant activities. It's a multifunctional protein. In 2017, we published this study where we found reduced salivary levels of lactoferrin in patients with mild cognitive impairment with prodromal Alzheimer's disease and dementia due to Alzheimer's disease compared to healthy control subjects. In fact, based on these findings, we propose salivary lactoferrin as a novel and potential AD diagnostic biomarker. Due to the relevance and our surprise with these findings, we decided to continue we performed a new study using two independent cohorts, not only with Alzheimer's disease patients, but also with patients suffering from frontotemporal dementia, in order to evaluate the diagnostic utility of salivary lactoferrin in Alzheimer's disease. We found very briefly in the first cohort we studied, we found that the salivary lactoferrin levels in mild cognitive impairment patients and Alzheimer's disease patients, both of them with amyloid PET positive, these patients showed reduced salivary lactoferrin levels compared with the control subjects, and this reduction was not observed in patients with frontotemporal dementia. In the second cohort, we obtained very similar results. And using logistic regression models, we found that the sensitivity and specificity to discriminate patients with mild cognitive impairment with early prodromal AD and dementia due to Alzheimer's disease versus compared with controls, the sensitivity and specificity were very, very important, around 87 and more than 91%. And even these values of sensitivity and specificity to discriminate, in this column, to discriminate dementia, frontotemporal dementia and dementia due to Alzheimer was also very high. More recently, I'm studying in collaboration with the group of the Dr. José Luis Cantero. The authors reported very interesting results showing that salivary lactoferrin levels were associated with brain amyloid beta load and with poor memory in normal aging, not in patients, but in adult, in older adult subjects. Then these findings support the role of lactoferrin, salivary lactoferrin, as a biomarker of cerebral vulnerability in normal aging. And then, we can obtain more more information about the role of salivary lactoferrin in the continuum aging Alzheimer's disease. But the question is why these salivary lactoferrin levels are reduced in these patients. Well, in this article, we propose as a hypothesis that low salivary lactoferrin levels may reflect a dysfunction in the immune system in Alzheimer's disease. Here, in this study, in fact, we discuss the relation and the interaction, the bidirectional interactions between the nervous system and immune system, as both of them work in coordination in host defense. Additionally, it is important to note that in Alzheimer's disease, amyloid beta and tau may accumulate in different brain areas, including hypothalamus, affecting its normal functioning. And as since hypothalamus regulates body basic functions, hypothalamic dysfunction induced by these aggregations may represent a immune system dysfunction and an immune system dysregulation. Thus, we propose that salivary lactoferrin may reduce due to the downregulation of the immune system associated with these hypothalamic alterations. Moreover, salivary protein secretion is controlled by parasympathetic nerves connected with the hypothalamus, and the secretion of lactoferrin is regulated by cholinergic parasympathetic nerves that release acetylcholine that joins muscarinic receptors and induce the secretion of lactoferrin from the acinar cells in the salivary glands.
Eva, sorry to interrupt. We have approximately 1 minute.
Yes, 1 minute. Then to demonstrate this hypothesis, we used a double transgenic mouse model of Alzheimer's disease, and we found a reduction in the salivary levels, in the lactoferrin levels in these mice, but also a reduction in the levels of acetylcholine and muscarinic receptors in these mice. Thus, as conclusion, we suggest that the salivary lactoferrin could be a very good and a very potential diagnostic AD diagnostic biomarker due to its non-invasive and cost-effective. And this also could reflect oral dysbiosis and facilitate the oral pathogen proliferations. Thus, it's important to check healthy our lifestyle and paying attention with the infections. Thank you so much for your attention. I'm sorry for the delay.
Thank you so much. And I have some questions for you. I'm sure the audience does too. So we'll continue those during our panel discussion. Thank you again, Eva.
Thank you.